Drainage innovation at the Huronview Demonstration Farm. Environmental monitoring on the farm. A closer look at what's in the water. In the video on water quantity, it was mentioned that the Huronview Demonstration Farm is monitored for both water quantity and water quality. This video will focus on what is water quality, the equipment needed in the field to record these measurements, and how these measurements can be turned into more meaningful information. Water quality refers to the nutrients such as nitrogen, phosphorus, or sediment dissolved in a sample of water. It requires its own set of steps for turning what we see visually in the field into data that can be used for the analysis that will ultimately help us answer the 4 guiding questions mentioned in the first video. Similar to water quantity, we use monitoring equipment to record this data. To collect water samples, once again, a dedicated monitoring spot is needed, and preferably at the same location where flow data is collected. The pooled water behind a weir works for both surface and tiles when collecting water. Water can be collected manually by having a person come on site at a specific time and grabbing a sample with a bottle. To make that process more efficient, automated water samplers that use a suction tube and a pump can be used to draw water up and deposit that water into bottles. The automated water samplers used at Huronview are called ISCOs, and they have a total capacity for 24 bottles. This means 24 bottles of water can be collected and shipped for lab analysis if needed. ISCOs are programmable, which allows the user to choose how often a sample is taken. This may be every hour or every 4 hours. Intervals can also be set to do every 30 minutes for so many bottles, followed by every 1 hour for so many bottles, and then every 4 hours. This is called non-uniform event sampling and is used at Huronview. After a rain event, samples will be collected in the field and brought back to the office. Not all 24 bottles are shipped for analysis, and instead anywhere from 3 to 6 bottles may be chosen for shipment to the lab. To choose these bottles, the time the sample was taken is graphed in relation to the hydrograph, that rising and falling of the water. At minimum, 1 sample is shipped when the water rises, 1 when it peaks at its maximum flow, and then 1 when the water starts to fall or recede. In some instances, lining the bottles up in a row helps to see color changes. These color changes often depend on the amount of sediment in a sample, which can be a helpful indicator when trying to use samples. At Huronview, during certain events, some or all of the samples can look the exact same, with color change not being a very reliable method for picking samples. In these cases, graphing flow with when the sample was taken is extremely important and must be done in order to select meaningful samples to be shipped to the lab. Samples that are shipped to the lab for analysis are examined for ammonia, nitrate, nitrite, total Kgel nitrogen, total phosphorus, orthophosphate, and total suspended solids. The lab sends the results back as a report, and each nutrient parameter will have a corresponding concentration value in milligrams per liter. Samples can be plotted on a graph to help visualize how these relate to the rising and falling of water flow during a rain event, seen here. In drinking water testing, concentration values are often used to see if a nutrient in water exceeds the recommended limit set out by the provincial guidelines for safe drinking water. In environmental monitoring, such as that's being undertaken at Huronview, concentration data is only one piece of data needed for water quality analysis. With concentration data, it is important to note that concentrations can become diluted with more water. This makes it difficult to compare tiles or streams if the amount of water is not the same between the 2 systems being compared. For Huronview, it's better for answering the 4 guiding questions if we can take the water quality concentration data and pair it with the flow data to help standardize the concentration against the amount of water passing through the tiles. To do this, we must calculate the load or the amount of nutrient exported based on the volume. This is the topic for the next video.